This is 3.5 with more trig derivatives. So we've done the trig derivatives for sine and cosine, but there are 6 total trig ratios. And so we need to do the derivatives for the other 4. So what we're going to do is for each of the remaining 4, we are going to derive them using the quotient rule. So they don't look like quotients yet, but they will in just a second because we're going to be using some of our trig identities to rewrite them. So what I'm going to do for secant is I'm going to start off by rewriting secant as 1 over cosine. So this is going to become the derivative with respect to x of 1 over cosine of x. And then, just like we do with quotient rule, I'm going to do a box. So the top of the box has a 1 and a cosine. The derivative of 1 is 0. The derivative of cosine is negative sine of x. So we're going to set up our derivative. We're going to do 0 times cosine of x minus 1 times negative sine of x all over cosine of x squared. And then we're going to clean this up a lot. So 0 times cosine goes away. And negative 1 times negative sine is positive sine. So we're going to have sine of x over cosine of x squared. And then I'm going to play with some trig identities to rewrite this in a more compact form. So I'm going to go ahead and I'm going to rewrite the cosine squared as cosine times cosine. So I'm going to say sine of x over cosine of x times cosine of x. And then I'm going to split these up. I'm going to assign the sine to one of these cosines. So just to make things simple enough, I'm going to take sine and the second cosine. So that just made this 1 over cosine of x times sine of x over cosine of x. Well, we know from the beginning of this that 1 over cosine of x is the same thing as secant. And sine over cosine is the same thing as tangent. That's one of your identities. And that is actually where we're going to leave it. That is the derivative of secant. So the derivative of secant of x is secant of x tangent of x. Okay, that's the formula that you're going to memorize. We're going to do the same thing for cosecant. So cosecant, when I rewrite it, I'm going to end up with the derivative with respect to x of 1 over sine of x. And then I'm going to do my quotient rule. So I'm going to set up my box. And I'm going to put 1 and sine of x in the top 2 boxes. The derivative of 1 is 0. The derivative of sine is cosine. And so then I'm going to go ahead and say 0 times sine of x minus 1 times cosine of x, all divided by the original denominator, which was sine, so sine of x squared. So simplifying that down, the 0 times sine is going away, so I'm left with negative cosine of x over sine of x squared. And to be clever, I'm going to then say minus cosine of x over, and just like we did for the other one, I'm going to split up the sign. So I'm going to write sine squared as sine of x times sine of x. And then I'm going to, just like I did before, assign the cosine to the sine of x. And that means that now I have the negative sign. I have 1 over sine, which is cosecant, and then cosine over sine, which is cotangent. And so this is the rule you memorize, that the derivative of cosecant of x is negative cosecant cotangent. And it's negative because when we did it the first time, we had 2 minus signs, right? The negative from the quotient rule and the negative because of the derivative of cosine. This time we only had 1 minus sign. Let's do the same thing for tangent. We've actually done this one before, but we'll do it again and kind of polish it off. So I'm going to take the derivative of tangent and I'm going to turn it into the derivative with respect to x of sine of x over cosine of x. So when I set up my box, I'm going to have sine of x in the upper left, cosine of x in the upper right. The derivative of sine is cosine. The derivative of cosine is negative sine. And then I start to write my derivative. So cosine times cosine. So we'll have cosine of x times cosine of x minus sine of x times negative sine of x over cosine squared. Well, cosine times cosine is cosine squared, so I'll write that as cosine squared. And sine times sine, with an extra negative sign, means I'm going to have plus sine of x squared over cosine of x squared. So then we're going to dip into our identities that we have, because cosine squared plus sine squared, or vice versa, sine squared plus cosine squared, is a Pythagorean identity and equals 1. So then I've got, and I'm going to write my squared that way this time, 1 over cosine squared. Well, the reciprocal identity for cosine is secant. 1 over cosine is secant. So 1 over cosine squared is secant squared. And so that is the derivative of tangent. Last but not least is cotangent. So for cotangent, I'm going to do the same thing that I did for tangent, except I'm going to turn this into the derivative with respect to x of cosine of x over sine of x. And so that's again a quotient. So we'll start our quotient rule. Cosine of x in the upper left, sine of x in the upper right. The derivative of cosine is negative sine of x. The derivative of sine of x is cosine of x. And so then we set up our derivative. So we're going to say negative sine of x times sine of x minus cosine of x times cosine of x all over sine of x squared. So now, if we keep going, and I'll kind of move down here and work into the margin a little bit, negative sine x times sine x is negative sine of x squared. Then we've got minus cosine of x squared over sine of x squared. Both of those in the numerator have negative signs, so I can factor that out. I can make that negative times sine of x squared plus cosine of x squared all over sine of x squared. And because of our Pythagorean identity, sine squared plus cosine squared is 1. So we've now got -1 in the top. And 1 over sine is cosecant. So 1 over sine squared is negative cosecant squared. And we're going to write it just like that. So those are going to be 4 formulas that you memorize. Commit them to memory, put them on index cards, remember them all the time. What I like to tell people is each rule always has 2 secants and a tangent. So if you look, the derivative of secant has another secant and a tangent. So there's 1 tangent and 2 secants. The derivative for cosecant has a cosecant and a cosecant and a cotangent. The derivative for tangent has a tangent and a secant squared, so that's 2 secants. And the same thing for cotangent, a cotangent and 2 cosecants. So there's always 2 secants and a tangent in your rule. And if you take the derivative of something that starts with the letter C, cosecant, cotangent, cosine, your answer is always negative. So if it starts with a C, it's negative, and there's always 2 secants and a tangent in your rule. Okay, so let's use that to try these 2 examples at the bottom of the page. Okay, so we've got tangent. We're going to have to use our derivative of tangent formula. So we've got that. We know what that is because we've got it right here in blue. Okay, we know that it's going to be secant squared. But the x is not by itself, which means chain rule. So I'm going to say outer, derivative of the outer, inner, derivative of the inner. The outer is tangent of something. The inner is the 2x. The derivative of tangent, if we use our rule, the derivative of tangent is secant squared. So we're going to have secant squared of something. And the derivative of the inner is 2. So we take our derivative, we say y prime equals, we're going to do derivative of the outer, so secant squared of the inner, 2x, times 2, or 2 secant squared of 2x. Same for the cosecant. So we've got negative cosecant of x squared plus 1. So I know I'm going to have to take the derivative of cosecant, so I do a quick look. There's cosecant. The derivative is cosecant cotangent. So this one is a little interesting. When you have 2 trig ratios in your derivative, you have to be very careful. Now I notice that the x is not by itself, so this is a chain rule problem. So I'm going to say outer, derivative of the outer, inner, derivative of the inner. The outer is negative cosecant of something. The inner is the x squared plus 1. Derivative of the outer is going to be the negative of the negative cosecant parenthesis tangent parenthesis. So this negative that's out front here is the negative that came with the problem. The negative that's inside the parentheses is the negative that comes with the derivative rule that's up here that I'm underlining again in yellow. Okay. Your derivative has 2 spots for an x. So you're going to need to put 2 spots for your inner function. And then the derivative of the inner is 2x. So we're going to say f prime of x equals, we'll start with the derivative of the outer. Now we can get rid of the negative signs because it's negative, negative. So we're going to have cosecant, parentheses, tangent. Ooh, cotangent. I put tangent. Bugger, bugger, bugger. Wait, let me fix it. Cotangent. There we go. Whoops. All right, so let me fix it here. Cosecant, cotangent of parentheses. In the parentheses goes your inner, and it goes in both places. And then we multiply by the derivative of the inner. And to avoid any confusion, we can bring that 2x up front, make it 2x cosecant of x squared plus 1 cotangent of x squared plus 1.